Okay, so we've been talking about fractions. We talked about reducing fractions and renaming fractions. Today we're going to start with operations with fractions. First place we're going to start is with multiplying fractions. So let's go 3/5 times, oh, I don't know, 2/3. When we multiply any number, first of all, do we need the same name? No. We can do something like 5, I don't want to do inches probably yet. Well, inches will work. We're going to do something like 5 inches times 2 pounds. And that works out. You get 5 times 2 is 10. Inch times pounds is inch pounds. You combine the counts. 5 times 2 made the 10. Then you also combine the names. Inches times pounds is inch pounds. Same thing happens with fractions. You combine the counts. Well, in a fraction, the counts are just the numerator. So you're going to multiply. 3 times 2 is 6. Then you also combine the names. The names are the denominator. So you're going to multiply 5 times 3 is 15. And now, of course, looking at that, you realize that that can be reduced by both 6 and 15 can be divided by 3 to give us 2/5. Now, some of you might be looking at this original problem asking yourself, why didn't he cross-cancel? Right about now, others of you might be asking, what's cross-canceling? Well, what it is if you look at this, you realize that this is going to become 3 times 2 over 5 times 3. And because of that, you realize here we only reduced by dividing by 3. But you can see right here that you could actually divide out the 3. All cross-canceling is sometimes called cross-multiplying, but that's a deceptive name. What cross-canceling is just a way of reducing before you multiply. We could look at this and say, hey, both of these can be divided by 3. We'll make it 1 and 1. Now 1 times 2 is 2, and 5 times 1 is 5. So you've reduced it before you multiply. Now in a problem like this, it's about the same level of difficulty either way. You can reduce it before or reduce it afterwards. But we do run into some where it is extremely easier to reduce before. For example, we might have like 24/25 times 35 over 36. We could go ahead and multiply that out and get 840 over 900. But we're working with big numbers and we're going to have to reduce them. Or we could see, hey, 24 and 36 can both be divided by 12. That's 2 and 3. 25 and 35 can both be divided by 5. That's 7 and 5. 2 times 7 is 14. 5 times 3 is 15. 14/15 is what that would, if we had multiplied it out to get 840 over 900, it would have been reduced to 14/15. It's just a lot easier to reduce it beforehand. We're not going to waste a lot of time on simple fractions. We're going to move up to mixed numbers, like 2 3/4 times 5 and 1/7. Multiplying mixed numbers is very, very tough. In fact, if we went over here to the UW across the street and we found 10 math majors, I'd be willing to bet that none of the 10 of them could correctly multiply mixed numbers. So what do? We avoid it. We turn them into improper fractions. 2 times 4 is 8, plus 3 is 11, so we make that 11/4. Times 5 times 7 is 35, plus 1 is 36, so that's 36/7. And then we multiply. Now, just like before, we can cross-cancel. 4 and 36 are both divisible by 4, which will give me 1 and 9. So 11 times 9 is 99. 1 times 7 is 7. And now we can reduce 99 divided by 7. 7 goes into 9 once. There's 2 left over. Bring down the 9. 7 goes into 29 4 times. That's 28 with 1 left over. So 14 and 1/7. I'm going to have you guys try a mixed number multiplication quick. You guys get that all done? All right, let's do 5 3/8 times 4 2/3. So I'm going to pause this and let you guys try that, and we'll check. So first step, improper fraction. What's this first one going to become? 43/8. Good. 5 times 8 is 40, plus 3 is 43. Second one? Yeah, 4 times 3 is 12, plus 2 is 14, 14/3. From there, what should we do next? Cross cancel. Which ones? 14 and 8 can both be divided by 2, which will give me 7 and 4. 43 times 7, 301. 4 times 3, 12. And now we have to reduce it. So 12 goes into 30 twice. That's 24. 36. Bring down the 1. 12 goes into 60. 5 or 61. That's 60. 1 left over, so it's 25 and 112. How many of you had that? How many of you know how to get there now? Okay. Good. Now, let's look at dividing. We've said that division and multiplication are really the same operation. It's just one's forward, one's backwards. So when we multiplied straight across. Does that mean when we divide, we can just divide straight across? No. Can we do here 12 25ths divided by 4/5? Can I do 12 divided by 4 is 3, 25 divided by 5 is 5? Does that give me the right answer? Yeah, that's the right answer. Would that work every time? Sure it would. So why don't we do it that way? Well, we don't do it that way because we run into things like this. 3/4 divided by 2/3. Well, 3 divided by 2 is 1.5. That's not going to work out so well. Even worse, 4 divided by 3 is 1.333333333. It doesn't divide out evenly. How were we taught to do that? Yeah, the 3/4 doesn't change, but the number we're dividing by, instead of dividing by 2/3, you multiply by the reciprocal. Good. The reciprocal is just taking that fraction and flipping it over. So 2/3 becomes 3/2, 3 over 2. Exchanging the numerator and denominator. Now, of course, you just multiply. 3 times 3 is 9. 4 times 2 is 8. 9/8 or 1 1/8. Well, believe it or not, that multiplying by the reciprocal, just like borrowing and carrying that we talked about with whole numbers, is a relatively new process. The actual process of dividing fractions, 3/4 divided by 2/3, once upon a time would have looked like this. We're dividing by 2/3. So we take the 2/3 and we do 2 times 3 is, not everybody at once, there we go, 6. So what that 6 is telling us is we use that to rename this first fraction. So 3/4 is going to get renamed by multiplying by 6 over 6, which is 3 times 6 is 18, 4 times 6 is 24. Now that's still equal to 3/4. We just changed its name. And now we can divide by 2/3. Well, guess what? Now we can just divide straight across. 18 divided by 2 is 9. 24 divided by 3 is 8. Otherwise known as 1 1/8. So the question is, how on earth did we get from this to just dividing by the reciprocal? And it's not as big of a stretch as you'd think. Once upon a time, somebody looked at this and said, hey, instead of doing the 3/4 times the 6 over 6 first, if first we were able to divide, 6 divided by 2 is 3, 6 divided by 3 is 2. If we were to do that division first, what we get here is always this fraction flipped upside down. So they gave it a name, they called it reciprocal, and said, hey, instead of going through this whole process, we know that the net result is just going to be take the reciprocal of that number and multiply. So that's where that multiplying by the reciprocal came from.
So basically, got lazy about his math.
Well, he just noticed a pattern and realized instead of going through that whole process, we can just do this and skip to the end. And yeah, it's just getting lazy and not wanting to do all the steps. So make it easy on yourself. So anyway, let's look at another example. We might have, well, let's jump to mixed numbers again. What the heck? 5 1/3 divided by 2 3/4. Now, since we're going to multiply by a reciprocal, if we're changing it to multiplication, it makes sense we would follow a similar process to multiplication. In other words, we're going to change them into improper fractions. 5 1/3 becomes 16/3. 2 3/4. 11/4. Good. Now, it would be really tempting here to cross cancel the 16 and the 4. Why can't we do it? Yeah, right now it's division, it's not multiplication. We can only cross cancel in multiplication. Now we're going to make this multiplication in our next step. The 16/3, remember, does not change. The only thing that changes is the number we are dividing by, which is the 11/4. So that's going to become 4/11, and now we are multiplying. 16 times 4 is 64. 3 times 11 is 33. And then we can reduce. That is 1 31/33. Any questions? Any of it? We can keep going over examples. We'll stick with it for a while. Okay, so let's do another example of division. Let's have you guys try one. We do 7 1/2 divided by 2 2/3. In fact, let's work through another example together first before I let you guys try one. So step 1, you're going to be making them improper. So 7 1/2 becomes how many halves? Yeah, 7 times 2 is 14 plus 1 is 15 halves. 2 1/3 becomes how many thirds? 8. 2 times 3 is 6 plus 2 is 8. So this is 8/3. Now this is still division at this point. So that means no cross canceling yet. What's our next step? We're going to take the reciprocal. Which fraction do we find the reciprocal of? It's the one we're dividing by, the one after the division sign. So the 15/2 will not change. Instead of divided by 8/3, it becomes times 3/8. Now we could cross cancel if we wanted to, but there's nothing to cross cancel. So we're just going to multiply. So 15 times 3, 45. 2 times 8 is 16. Or 16 into 45, we can divide that out. It goes in there twice, that's 32 with 13 left over, so 2 13/16. How are we doing? A little better? Let's have you guys try one. So I'll give you guys a second to give that one a shot. So first step, tell me what to do. So 23/4, good. 4/3. So cancel out the 4s? No. We're still dividing. Perfect. Perfect. Take the reciprocal of the 4/3, it becomes 3/4. Now it's 23/4 times 3/4. 23 times 3 is 69. 4 times 4 is 16. And that does reduce to 4 5/16. Cool. Let's do one a little bit trickier here. Not really a little bit trickier, but sometimes it is because it's just some people just don't know where to start on. 3/4 divided by 8. How do you do a fraction divided by a whole number? There we go. This has to become a fraction. So we make it 8 over 1. Then what? Well, just like any other division now with fractions, the 3/4 doesn't change. This becomes times 1 over 8. So 3 times 1 is 3. 4 times 8 is 32. It is 3/32 instead of 3/4. Let's see here. We have 9 divided by 3/4. Same thing for a whole number divided by a fraction. The 9 is going to become 9 over 1. And then it's going to, instead of divided by 3/4, it'll be times 4 over 3. What's next? There you go. We can cross cancel the 3 and 9. This is going to become 1 and 3. So 3 times 4 is 12. 1 times 1 is 1. So it is just 12. Any questions? Now I'm going to show you something a little bit trickier. What if well, let's just go to it. We have 4/9 times 3/8. We talked a little bit last week about when we reduce a fraction, how we could actually use factoring and cancel out common factors. Remember doing that? The same thing can happen here. We could factor the 4/9. That could actually become 2 times 2 over 3 times 3. And the 3/8, well, the 3 isn't going to change, but 8 is 2 times 2 times 2. And so for our cross-canceling, we could use those factors. We can see we can cross-cancel a 2 and a 2, and another 2 and another 2, and a 3 and a 3. Then multiplying out, there's nothing left on top. What does that mean? It's a 1, and 3 times 2 is 6. It is more confusing than simplifying, but the reason I had to show you that is now we're going to throw in stuff like this. Sure. Something like that. There are a couple of ways we could approach this. We could just go ahead and multiply. We could forget about cross-canceling and just multiply it out and then reduce it later, which is just fine. And I'm going to trust you guys can handle that on your own. But if we don't want to go through all that work, we can do this. We can take out the numbers. We can treat the numbers and the variables separately. Let's pull out the numbers. 3/4 times 10/15. We can cross cancel the 3 and the 15 to make 5 and 1. 4 and the 10 we can cross cancel to become 2 and 5. 1 times 5 is 5. 2 times 5 is 10. Now, of course, that can still be reduced 1/2. Good. Now, what that's telling us is the numerical part of our answer is going to be 1 over 2. Next, we're going to do the variables. Now, I'm going to combine. On the top here, I've got b, and then I have a to the 5th. On the bottom, I have a squared and b to the 3rd. First thing I have to do is look and see, hey, is there anything that I can like combine on top? It's not like I have a b and a b squared or anything like that, right? They're both separate. If there was like a b and a b squared, I'd combine them to make b to the third or whatever. We'll look at an example like that in a second. For right now, though, there's nothing I can combine. So now I'm going to look at reducing this just like reducing a fraction, which is really what I'm doing. Which one's going to go first, A or B? I should use A first, because remember, alphabetical order. Very good. So where's the A going to go, top or bottom? It goes on top because the bigger power is on top. And what's the power going to be? 3. Good. 5 minus 2 is 3. Where's the B going to go? On bottom, because the bigger power was on bottom, and its power will be 2. Good. 3 minus 1 is 2. So there it is, 1a to the third over 2b squared. Now, and technically, we don't even need the 1 on top. We can just make this a to the third over 2b squared. That's our answer. Not so bad. Or we could have something like this. So we pull out the numbers. Seven ninths and 3/4. We can cross cancel the 9 and 3 to get 1 and 3. 7 times 1 is 7. 3 times 4 is 12. Everybody's okay with the number part of it?
Yeah.
Okay. So we got the 7 and 12. Now let's pull out the variables. And this one's going to be a little trickier. This fraction here, we've got a b to the third on top, and there's nothing on bottom. The other one, we've got b squared over a. B to the third times b squared is b to the fifth. 1 times a is a. Is there anything to reduce there? No, there isn't. So that's it. Right there. You look confused, Cody. No?
Well, I got that one. It's just the last one. If I'm right, it's supposed to be a to the third, b to the second.
Yep, a to the third over 2b to the second.
Okay, I did it. Got it now.
Okay. Go back up. All right. Let's try this one. What's different about this one?
Well, it's high.
There it is. It's division, not multiplication. Which means before we even start, we have to do what? Okay. First one does not change. First fraction stays the same. The second one's going to become times, and we're going to do this reciprocal of the second one. So 40y over 21x to the third. So 14 over 25 times 40 over 21. We're pulling out just the numbers. And now we have 14 and 21 is 2 and 3. Both can be divided by 7. 25 and 40 can both be divided by 5 to give me 5 and 8. Then what? Multiply. 2 times 8 is 16. 5 times 3 is 15. The top's bigger than the bottom. Is that a problem? No, we cannot do that. When there's variables in there, remember, we cannot make it a mixed number. It has to stay as an improper fraction. So this would be 16 over 15. We really, really want to make it 1 and 1/15 because we're so used to doing that. But we can't. And then with all the variables. Yeah, we don't know what the variables stand for. So the top, it looks like that it's a 16 up there, so it looks like the top is bigger than the bottom, but we don't know what the variables stand for, so we don't know if the top's bigger than the bottom. So now the variables we're going to pull out. We have x to the 7th over y to the third. Then we've got y over x to the third. So if we multiply that out, well, it's just x to the 7th y over x to the third y to the third. I put them in alphabetical order. And it's a matter of subtracting. The x is going to go on top because the 7 is the bigger power, and it will be to the 4th. 7 minus 3 is 4, so x to the 4th. Y is going to go on bottom, and it'll be 2, because 3 minus 1 is 2. We will deal with some of those more later. No, it won't. But it's just, I don't know if my math lab would consider it wrong either. But if you put it in and it does say it wrong, that'd be the first thing I would check is alphabetical order. So our next step, adding fractions. When we add fractions, when we add or subtract any numbers, we must have the same name. Well, in fractions, that becomes common denominator. So the first step is figuring out what that common denominator is. Now, there are a few different strategies. One thing you can always do is just multiply them together. 5 times 4 is 20. That will be a common denominator, always. But it may not be the smallest one. That doesn't mean we can't use it. We could go ahead and use that. Even if it's not the smallest one, it'll work out. We'll just have to do some reducing when we're done. Another strategy we can use is making lists. If you count up by 5s, you know that's going to be 5, 10, 15, 20. You know what that list is going to look like, right? We've done 5s often enough. So let's do 4s. You have 4, then it would be 8, and then plus 4 is 12, 16, 20. Hey, we found a number that's the same in both lists, the 20. So we know that's a common denominator. The list tells us there's no smaller ones. So that's the smallest common denominator. There's another way we could do it. Remember we talked about that factoring before? We talked a little bit about least common multiples. 4 factors into 2 times 2. Well, 5, it factors into just 5. There's no way to split it up. It's prime. If you look at the factors, this one has the 2's, but it needs a 5. This one has a 5, but it needs the 2's. They both multiply up to 20. So no matter how we look at it, in this case, all 3 methods give us 20 as our common denominator, so maybe we should just accept that 20 is what we're going to do. So we got 2/5 plus 1/4. I always set up all my additions vertically because that's how I'm used to adding. Sure. So now we're going to make our common denominator as 20. What do we multiply 5 by to turn it into a 20? 4. So I have to do 2 times 4 is 8. What do we multiply 4 by to turn it into a 20? 5. So 1 times 5 is 5. Now that they have the same name, we're going to keep the same name, and we're going to combine the counts. 8 plus 5 is 13. So we get 13/20. Let's look at another example. 1/6 plus 3/8. First thing we need is a common denominator. Now, some of you might be able to see this one. Here, if we multiplied 6 times 8, it would be 48, which is a common denominator. It will work, but it's a little extra work, is all. There's a smaller one we can use. To find it, let's look at this. Let's factor. So 6, if I factor it, is just 2 times 3. 8 would be 2 times 2 times 2. Looking at those factors, they share a 2, but the top one needs 2 more 2's. The bottom one has all the 2's, but it needs a 3. To multiply each of those out, they both come out to 24. 24 is our common denominator. So do we have to multiply the 6 by to turn it into a 24? 4. So 1 times 4 is 4. 8 times 3. So 3 times 3 is 9. So 4 plus 9 is 13. And we keep the same name, 24. How are we doing so far? Lost? Okay. Well, let's just keep going with it. Let's say we have 5/8 plus 1/3. First thing we have to do is find a common denominator. Is that the part you're struggling with, is finding the common denominator? All of it? Okay. Okay. Well, let's keep working with them. So we've got the 8 and the 3. Our common denominator is going to be 24. The way I know that that's going to be the common denominator is the 3 is prime, so it can't factor. If one of the numbers is prime and you can't factor it, just multiply them together. Or if you're struggling with finding a common denominator at all, just multiply them together. 8 times 3 is 24. That's going to work as the common denominator every time. Now we just have to go back and adjust. What did we multiply 8 by to turn it into a 24? Well, 8 times 3 is 24. So we have to multiply the numerator of that fraction by the same thing. 5 times 3 is 15. Down here, to turn the 3 into the 24, is 3 times 8 is 24. We have to multiply the numerator of that fraction by the same thing. 1 times 8 is 8. Now they both have the same name, so we're going to keep that same name of 24. And we're going to add the counts. 15 and 8 make 23. So that's 23 24ths. We might have trying to think here. I don't do that. Something like this. 5/9 plus 1/12. You can find the common denominator. Well, we could mess around with the 9 and 12 and find the least common denominator, by the way, would be 36. But if you're messing around with it, I put these up there intentionally. Those are tough numbers to find a common denominator. You can always just multiply them together. What's 9 times 12? It's 108. So what that means is the 9 had to be multiplied by 12. So we're going to do 5 times 12 is 60. The 12 was multiplied by 9, so we do 1 times 9 is 9. And now we can add. Well, the 108, we keep the same name. 60 plus 9 is 69. Here's why it was easier to find the least common denominator instead of using the 108. Because now we have to reduce this. And at first glance, it's not really obvious that you can reduce that. But remember the sequence we always go through. Can they both be divided by 10? No. 5? No. 2? Well, the 108 can be divided by 2, but 69 can't. What's the next one we look for? 3. Can they both be divided by 3? Yes, they can. 69 divided by 3 is 23. 108 divided by 3 is 36. That's 23 over 36. You said before, 36 is the least common denominator. We could have used 36, and we could have had that right off. At this point, I think got like 2.5 or 3 minutes left. I think it's best to cut it off, let you guys work on it. We'll discuss this more on Wednesday. So there is a new homework to work on. Well, there's a new quiz, by the way, that's due tomorrow, Tuesday at 11:59 p.m. And then there is a new homework due on Wednesday. I may end up extending that one because we didn't get quite through all the material for that one. So we'll finish that stuff up on. We got through almost all of it, but we'll finish it up on Wednesday. Maybe extend that.